So, hello students. Today we will see about the fluid flow and its properties. Fluid flow and its properties. So, as you all know that, what is fluid? What is fluid? And how we define the fluid? Say water. Say the Coke. Or say the gas. Clear? Now, if you will be putting the water in the glass, it will take the shape of glass. If you will putting water on the round shape bowl, it will take the shape of bowl. So, which indicate that the fluid have flexible shape. Correct? That means they are not rigid. Clear? Is it clear? Now, we know that there are two types of fluid. First is liquid. Second one is gas. Clear? So the liquid are non-compressible, ideally. But up to certain extent, the liquid also can be compressed. But as compared to gases, they are highly compressible. Right? If you can see a very simple example, the syringe with doctor use, right? Is it? Diagram is very poor. Okay, when you take the air in, is it? So the some amount of air will be trapped inside the hole, inside the vacant space. And if you press it, if you close the knob, the outer knob, and if you will apply force here, the gas will start compressing. It will compress up to certain extent such that it will apply the equal force. After that, you will not be able to compress it again. That means when you will compress, the gas will also apply another force, and more you will compress, the gas pressure opposite to your force will also increase. And after a certain point, your force will be equal to the gas force, beyond which point you will not be able to compress it. Clear? Moreover, if suppose in a container there are some gas, so it will acquire the volume is equals to container, right? So the volume of gas will be is equals to volume of container. Clear? Whereas it will the fluid, basically the liquid, also acquire the shape, but the volume will be fixed for the liquid. Suppose if you are putting 2 meter cube of water, you are putting 2 meter cube of water inside a jar, having volume is equals to 5 meter cube. So it will not happen like the water will be converted into 5 meter cube. It will remain as 2 meter cube. That means if we'll put in any container, the volume of liquid will remain same. Okay. But whereas in case of, if you will put the same amount of gas in a jar, it will take the volume of jar. If you will put the same amount of gas in basically we can say sphere, so it will take the volume of sphere. Now another properties is, if you will change the temperature and pressure of gas, so they will react very quickly and appreciable changes can be observed, right? That means if you will increase the temperature, they will show the reaction suddenly with the change in temperature. They will increase their volume, they will increase the pressure, is it? Similarly, for the pressure, if there is change in the pressure, the gaseous form will be showing the fluid form of gas in the gaseous form. They will show a very drastic and appreciable change in their composition. Composition in the sense they will change their volume, they will change their force very quickly, the pressure very quickly. Okay. Because now if you will increase the pressure, suppose if you put the gas in the container, and now if you are increasing the pressure, so the force on the container, the pressure on the container wall will be increasing, the volume will be decreasing. If you further compress, the temperature of the gas will increase. Temperature of gas will increase. Okay. Okay. I hope the difference between liquid and gas is clear to you. The liquid are non-compressible, gases can be compressible. The gases shows very drastic behavior or appreciable changes on its composition when they are subjected to the temperature and pressure. Whereas if the liquid is subjected to temperature and pressure, the temperature will increase or temperature will decrease of the liquid, but they will have very rare change in the volume. They will have very rare change in the pressure. Okay. Okay. So if this part is clear, then we can move to the next part. That is the branches in the fluid mechanics. Right. So have you observed that there are the fluid kept in the container? Suppose there is truck. This is looking like jeep. So suppose this is jeep, this is full of water and it is moving. Okay. Now there is a piston and fluid is filled inside it. Okay. So in fluid, basically it have three branches. First one is when we study the science behind the fluid when it is in the static condition. Is it? Fluid in static condition means the fluid is at rest, the fluid is not moving, it don't have any velocity, it don't have any acceleration, just fluid is standing at its own position, right? Similarly, in the fluid kinematics, we study the science behind the fluid when it is in the motion. Then fluid is in motion. Okay, that means it have velocity and acceleration. Clear? Now there is another branch in which we study about the fluid forces when it is subjected, right? When we apply the fluid forces, they will start moving. Okay, so the study of application of fluid forces and its motion and change in shape, position. Okay, so when we apply the force on the fluid, they may get some acceleration, they may get some velocity, they may deform their shape, they may change their position, right? So all these three types of study is basically conducted in the fluid mechanics. Okay. Now one can ask why we need to study fluid mechanics, right? So there are various applications of fluid mechanics, such as the very basic example, ships, submarine, right? Submarine, aeroplane. These two deals with water as a fluid, and aeroplane deals with gas, basically our atmospheric gases. Okay. Similarly, in food, you have study about HTST, right? So what we pass either fluid, that can be water, that can be gas, right? In order to warm the food, in order to cool the food, in order to heat exchange, is it? So in that aspect, the fluid mechanics is very important. In most of the cases, right? In heat exchanger, they are telling, okay, at this rate we are transforming. Why we have to choose particular rate? Because if we will be supplying the particular rate, then there will be fluid. The fluid may come in contact, or fluid may communicate with each other in terms of heat exchange, right? So it is all about the fluid mechanics. How much rate we have to transfer the fluid in order to desired output. Say we want to take the product, say any food product, at particular temperature. So if we are passing the fluid with so much speed, it may not get that desired temperature. If we are passing too slow, then it can overheat, or it can overcool the output product. So there is particular velocity, there is particular amount which we have to pass so that we can obtain the desired product. I hope the necessity of the fluid mechanics is clear to you. Okay, now we will move on to the important section of the fluid. And the important section is fluid properties. Clear? So you know that the fluid have various properties, such as density. And the formula you know, right? The density. Density is nothing but mass upon volume. Mass is in kilogram, volume is in meter cube, right? So the unit of density is kilogram per meter cube. Similarly, if you will represent in terms of dimensional formula, it will be ml raised to power minus 3. Clear? So if the density is mass by volume, so what will be the density of fluid? Mass of liquid divided by volume of liquid or volume of fluid, is it? If the density of liquid, you are talking about density of liquid. Clear? Another terminology is specific gravity. So you know what is specific gravity? It is nothing but it is the relative comparison of the density, or basically we can say relative comparison of density of substance with respect to water. Now it is nothing but density of substance This substance can be any liquid, and liquid can be say mercury, say any juice, any food product, liquid product, right? It can be solid, etc. So the specific gravity is density of substance divided by density of water, and the density of water we consider at 4 degrees Celsius. Why? Because at 4 degrees Celsius the water has maximum density. Clear? So it's, if we talk about its unit, so we know that density of substance is nothing but mass upon volume. So that is kilogram divided by meter cube divided by density of water, kilogram of water per meter cube. So it will cancel out and it have 0 unit. 0 unit means m raised to power 0, l raised to power 0, t raised to power 0. So the specific gravity, since it is the ratio, so that's why it is unitless quantity or dimensionless quantity. Clear? Similarly, another terminology is, let me change some good color. I hope this color is better. Now, the important terminology is specific volume. So what do you understand by specific volume? Anyone? So specific volume is nothing but how much volume a substance or a product, a food product, a product we can say, have for its unit mass. Clear? How we can define? We can define it as, like, say, x meter cube volume for 1 kg of mass. So this x meter cube will be its specific volume. In simpler term, suppose we have density is equals to mass upon volume, right? Is it? So specific volume is nothing but one upon rho, that is volume by mass. That means how much volume per unit mass. Clear? And what will be the unit? Unit will be meter cube. For volume it will be meter cube. Mass it will be kg, right? So what will be the dimensional formula? dimensional formula of specific volume will be, since it is L cube m raised to power minus 1. I hope it is clear. Another important terminology for the fluid is vapor pressure. Clear? You know, for each the fluid, if we keep in the room temperature, for every temperature there will be a fluid who will be exerting the vapor will be coming out of the fluid, and they will be exerting the force, and that is known as the vapor pressure. And mostly if the fluid is in closed container, so there will be some fluid vapors definitely, so they will be exerting some pressure, force on the container wall. That pressure is known as vapor pressure. It's very simple. Another terminology is adhesion. What is adhesion? What is adhesion? Anyone is having any idea? So adhesion is force between two different fluids, right? Similarly, cohesion. Cohesion is the force acts between similar molecules of fluid. That means it is the cohesion is between the similar fluid, whereas adhesion is between the two different fluid. Clear? Is it clear? Mostly two different fluid. Generally, the fluid should not mix. Clear? And the adhesion which we see generally is between solid and liquid. Solid and liquid. So if we put some water on glass, then we can see that, okay, some shape deformation change will be there, or basically there will be some forces between the wall and the surface, right? So that is due to adhesion. Cohesion is due to the fluid forces. Let me elaborate clearly. So the cohesion force will be between the fluid and fluid, right? Between the fluid and fluid. But adhesion force will be between the two different fluid, right? So it can be this molecule and this molecule, and this surface and this molecule, the water liquid molecule and the solid surface, or the liquid molecule and the air surface. Okay, air. Another property is compressibility. Okay, you all know that the liquids, the ideal liquid, are incompressible. Whereas gases are compressible. What is incompressible and what is compressible? When we apply some force, apply external force or pressure, right? If we apply external force or pressure, and if the volume or the deformation is taking place, volume basically, if there is change in the volume, then we call them as compressible. If there is no change in volume, then we call it as incompressible. In case of liquid, if you apply any pressure, you apply any pressure, the volume will not change. That's why we are telling it the liquid as incompressible, whereas the gases, when we apply the pressure, the volume will change. That's why we are telling the gases are compressible. Clear? Okay. Now, another important property of the fluid is viscosity. I will take one example. You have honey and you have water. Who is more viscous? Honey or water? Of course, it is honey, right? Why? Because it is thick? No, because it have higher resistant property to prevent the fluid flow. Suppose there are so many layers of honey. Similarly, there are so many layers of water, right? So the viscosity will depend on, suppose between the two layers, there will be more friction as compared to water, which will prevent the honey to flow on the surface freely, right? Of course, it will flow, but as compared to water, it will flow roughly, right? Because in between the parallel surfaces of the honey, or between, say, we can say the layers of the honey, the resistant force is higher. So the resistance force prevent the honey from the fluid flow, right? Whereas in case of water, the flow, the resistance between the layer is very low. That's why they can flow smoothly. That's why the water is less viscous as compared to honey. Clear? Now, for the real fluid, basically we know that all the fluids are compressible up to a certain extent. So the real fluid, they are compressible up to a certain extent. Clear? So the real fluid is further classified into Newtonian, the real fluid is further classified into Newtonian, non-Newtonian. Non-Newtonian fluid. So what are the properties of Newtonian fluid? Fluid which follows Newton law, right, are called Newtonian fluid. Whereas they do not follow the Newton law of viscosity, called non-Newtonian fluid. Clear? Any doubt so far? So, what is Newton's law of viscosity? I hope you know Newton's law of viscosity. Viscosity. So we know that real fluid are of two types: Newtonian fluid, non-Newtonian fluid. So Newtonian fluids which follow the Newton law of viscosity, and non-Newtonian fluid do not follow the Newton law of viscosity. But we should know, right, what is the Newton law of viscosity? So Newton law of viscosity says that the shear stress in the fluid is directly proportional to velocity gradient. Let's understand these two terms in more elaborative manner. Suppose we have the fluid, right? And if you start applying the force here, so this layer will start moving. Apart from that, a similar profile will be created, right? Suppose it is having y, and suppose the velocity is, here is u1, here it will be u2, right? So the velocity gradient will be rate of change of velocity with respect to y, right? With respect to y from here to here, right? This is u3. So the velocity gradient will be du divided by dy, considering it as a dy. So the shear stress is nothing but represented by tau, and its value is force upon area, right? These are proportional. Tau is nothing but here will be equal force upon area, whereas the tau is equal to du by dy, and a constant will come as mu du by dy. Du is change in velocity, dy is the particular depth, and mu, you know what is mu? It's a coefficient of viscosity. And mu is which? Kinematic or dynamic viscosity? Mu is dynamic viscosity. Dynamic viscosity. Clear? And what is the unit? Newton second per meter square. Similarly, let me make the comparison. We are studying in the Newton's law of viscosity, but I want to clear the dynamic viscosity and kinematic viscosity. Clear? So what is dynamic viscosity? Represented by mu. Kinematic viscosity represented by nu. What is the unit? Unit is Newton second per meter square. And for kinematic viscosity, this is meter square per second. And how we can identify kinematic viscosity is nothing but simple formula, mu by rho. Clear? And what is mu? Mu is dynamic viscosity, and rho is, what is rho? Density of substance. Right? So I hope the kinematic and dynamic viscosity are clear. Now let's come to our topic. We were discussing about the Newton's law of viscosity. So it is shear stress is directly proportional to velocity gradient. What is velocity gradient? Du by dy. And what is du here? Du here will be u2 minus u3 what is dy? Dy will be, say here y1, say upper height is y2, so it will be y2 minus y1. Clear? So I hope this step is very much clear to you, the Newton's law of viscosity. Clear? So these are the important properties of the fluid, right? So there may be some very small questions may ask, like how, if you have the dynamic viscosity, then find the kinematic viscosity, that you can find very easily. They may ask about the units of dynamic viscosity, units of kinematic viscosity. Clear? So you should not be confused. Sometimes in the formula, they will be, in the question, they will be giving the kinematic viscosity. They will give kinematic viscosity, but you have to use in the formula dynamic viscosity. So the formula also you remember very carefully. Okay. And the conversion you should remember, like if you want to find the kinematic viscosity, then you have to divide the dynamic viscosity by density. I hope it is clear to you.